Hello again, ladies and gentlemen. This is Mr. Smith, and this is 4.6, creating equations from graphs, tables, and words. This is going to tie in the last two lessons that we've learned from our Learning at Home segments, which would have been 4.3 and I believe 4.4 or 4.2. One or two of those three, I can't remember which ones exactly off the top of my head. So we're just going to do a little bit of review. And most of this is just an application of said lessons. Okay. Recall direct variation relations have the form dependent equals rate times independent. Partial variation, very similar to that. It has dependent equals rate times independent plus your initial value. So there's two pieces of information that you need for an equation of a linear relation. One is the rate of change, two is the initial value. Direct variation, the initial value will just be 0. Whereas partial variation, it will be anything but 0. So that's the only difference between the two. Direct variation will have your initial value equal to 0. Okay, let's go on to the next slide. Here we have two different graphs. We need to determine the equation of the linear relations from each graph. On the left, we have a direct variation, and on the right, we have a partial variation. And they each take different approaches on how to solve them. So for direct variation, you can actually take any point on the graph to solve for slope. So the point I would choose on this, because it's nice and rounded, is this point here signified by an x, which is 540. And to figure out your slope, or your m value, you're just going to put your y value, which is your rise, because you rise 40, you run 5, so 40 over 5. Now, these look similar, and that's because the scale is different, so be careful of the scale. Even though it goes up 40, it looks almost the same as going over 5, but it's not. Okay, so we have 40 over 5. Remember, if you use your ABC button, 40 ABC 5, you should get 8 over 1, which is just 8. Because anything over 1 is just 8. And because I said this was direct variation, that means that our initial value is, well, our initial value, which is b, should be 0. That means that our final equation is y equals mx plus b. For m, we sub in 8x, and then we have plus 0, but you don't have to write plus 0 because that is just redundant, so we don't write plus 0 at the end. It's just y equals 8x. That is our final equation for this example here. Just a quick recall. Y equals mx plus b. M is our rate of change, our rate, and b is our initial value. Okay. Next example, we can't just take a point to find the slope. We actually have to figure rise over run. If we go over here, we see we go over 5 because that's halfway between 0 and 10. And then we go up. Well, it's actually 5 units again. So 5, 5. So our slope, our m value, is going to equal 5 over 5. Which is just going to be 1, right? Because 5 divided by 5 is 1. What's our initial value? Well, when x is 0, we go up, we find it here. Our b value, our initial value is, you said 45, you are correct. So now we can just plug these into our y equals mx plus b. Y equals x plus 45. Now, you don't have to write 1 in front of the x, because if you do, it's just 1 times x, which is just x itself. 1 times anything is itself, so therefore you can just write x plus 45. Okay, that's your first 2 examples. Let's go on to the next. So for our next example, example 2, determine the equation of the linear relation from each table. We actually have to work our way backwards to solve for the missing values, but this will also help us determine how to calculate our rate of change as well as our initial value. Well, we need our first value there because that will be our initial value. And the way you actually do this is you figure out the difference in both the x and y values first. So first we're going to take the difference here. Well, it only went up 1. Here, 1 again, and here, 1 again. Well, if we follow this pattern, 4, 3, 2, 1, we're subtracting 1 if we go the opposite way. So that means that this initial x value is going to be 0, which is perfect. This is exactly what we need to find our initial value. Next, you do the same thing for our y values over here. And it should be the same each time. To go from 1550 to 1775, we're actually adding 225. And then to go from 1775 to 20, we're adding 2.25 again. Then from 20 to 22.25, we're adding 2.25 again. So to go backwards now, you actually subtract 2.25. And if you do that from 1550, you actually get 13.25. Okay, now we can actually determine, because this is our initial value here, right? That's our b value, because that's where we start. But then we also need to know how much we're changing each time, right? Because m is going to be what you change. Well, if you look right here, this is our m value. So we actually have y equals 2.25, because that's how much it changes, plus our initial value, which is 13.25. If you want, you could write n instead of x. Because this question uses n, you could have wrote n in where x is. Either way, I would have given you full marks. I'm not going to be too picky on that. Same with the c here. It would have been c equals 2.25 n plus 13.25. I'm not going to be too picky on that. That's okay by me. Okay, moving on to our next set of values, our next table of values. We need to work backwards again. Well, first we examine, what are we doing? Well, we're adding 2. We added 2 again. We're adding 2 again because we went 2, 4, 6, 8. We're counting by 2. So if we go the opposite direction, that means we're going to count down from 8, 6, 4, 2, and then it should be 0, which is great because that's our initial value. We need to determine that. Next, we determine how much we're changing on the right side. So we start at 45, and we went up to 90. What's the difference between 45 and 90? If you said 45, you are correct. And the difference between 90 and 35 is just 45. That's our rate of change. Difference between 135 and 180 is 45. And all you do is you subtract the bottom number by subtract the top number away from the bottom number. So 180 minus 135 would give you 45. Okay, so now we work our way backwards now. We're actually subtracting 45 as we work our way up. And 45 minus 45 is actually 0. So our initial value, our b value, is going to be 0. If we have b equal to 0, we need to figure out what m is going to be. Well, we have to be careful. Our m isn't 45. It may seem like that, but because we're increasing by 2 each time, like over here, you see how we're increasing by 2? We actually need to divide by how much we're running, right? Because you have rise over run. If we run 2 and rise 45, it's actually 45 over 2, which you could actually reduce down to 22.5. So your y value is equal to 22.5x plus 0, but we don't write plus 0, so that's our final answer there. That's our final equation. Again, you could write c and n, c for the y value, n for the x value, but I'm not going to be too picky on that. Okay, moving on to the next one. Example 3, determine the equation of the linear relation from the statement this time. Okay, a banquet hall charges $40 per person for a reception. Use C for the total cost and N for the total number of people. In this case, I would be picky about how you label your variables because I say very clearly to use C and N. C would be the total cost. What depends on what? Does the number of people depend on cost, or does cost depend on the number of people? Well, cost actually depends on the number of people, so C equals. So C is our dependent variable because the cost is going to change depending on how many people show up. Well, how much is it per person? If we look at our statement here, it's $40 per person. That's where I'm getting my 40 from. And N is the number of people. So C equals 40N. Let's try using the next, or let's try doing the next question. It'll be very similar. A different banquet hall charges $1,000 to rent and $25 per person for a meal. Use C for the total cost and N for the number of people. Well, what's our dependent variable? The number of people or the cost? If you said cost is the dependent variable, you are correct. The cost depends on the number of people that show up. How many people per person? $25 per person, so we're going to put 25 in here times N. However, we've got one difference. How much do we get charged at the beginning? Before anyone shows up, we still get charged $1,000 here. So that's where that $1,000 comes from. Next example, the cost of publishing a yearbook is $8,000 for the setup, and then on top of that, $4 per copy. Use C for the total costs and N for the number of copies. Well, we're going to set it up just like we did before. C equals. How much is our rate of change? Well, per copy. So it's $4 per copy if we have N for number of copies, and then plus our initial value. Well, it's $8,000 just for the setup. So that's our initial value. Next, we have Sam sells computers and earns 5% commission on her sales. Use C for commission and S for sales. Just remember 5% as a decimal, 0.05, right? Because you take your 5, divide it by 100, and that's how you get it as a decimal. So 5 divided by 100 gives you 0.05, and that's how I got that. So our commissions, or C for commissions, is 0.05 times, well, it's not N this time, it's S for sales. So if I'm being specific on the variables to use, you have to be very careful about what to use. Okay, that should be enough for you guys to get started on the practice. Make sure you do the quiz afterwards. If you have any questions, make sure you email me, as always. If there's any issues coming up, let me know so that I know that you need more time to work on it or you need extra help, and I will do what I can to help you out with that. Okay, best of luck.